Welcome to Lecture 27, 4.5 Exponential and Logarithmic Equations and Applications. Alright, so now we're moving into the equations, not just expressions. So we're actually going to be solving for a value. So first question, how do we know when an equation is an exponential equation versus like being a quadratic equation or a linear equation? Well, one of the main ways to know is your variable is going to be in the exponent. That's how you know it's an exponential equation. Versus, for example, an equation like this, which we know as a quadratic equation, where's our variable? Our variable is kind of down on the normal baseline, as I like to call it. Okay, so an exponential equation has your variable up in the exponent, hence the name exponential equation. Alright, so how do we solve them? Well, one of the main properties we're going to use is called the equivalence property of exponential equations. So if b, x, and y are real numbers, with b greater than 0 and b not equal to 1, then if we have this situation here, where we have one base that's the exact same as the other base, and they're two exponents, if the bases are the same, we can then equate the exponents, which means x equals y. So some people like to say the bases cancel out. Kind of not the way to say it, but that's a way you could think of it. So the bases would cancel out and we equate the exponents. So we equate the exponents. Let's take a look at an application of this. So for the first one, for a, what do we notice about this? Well, first off, I notice it's an exponential equation. How do I know that? Well, the variable's in the exponent. Alright, next thing, how do we solve this? Notice the base is 2 for each side. So because the bases are the same, we can then just equate the exponents. So x equals 4. And there we go. That's our answer. Pretty simple so far. b, however, looks a little different. Notice we have 3 to the y power on one side, but then we have 27 on the other. That's not something raised to a power. However, we can use our critical thinking caps and remember that 27 is 3 cubed. So this would be 3 to the y power equal to 3 cubed. And what do you know? The bases are the same. So when the bases are the same, what can we do? We equate the exponents. So y equals 3. Alright, so that's a very basic way of using the equivalence property of exponents. So now with exponential equations, there are two different types, as I like to call it. The first type, you can match the bases. For example, like with type B, we could make them both equal base 3. So if you can match the bases, what's our plan going to be? Well, first, match the bases, and then equate the exponents and solve, which is kind of what we've been doing before. So let's take a look at an example. Alright, so for some reason this got a little messed up. Hopefully I fixed this on your lecture notes. Let me go ahead and fix this problem. Alright, this is how it should have looked. Some of the formatting got a little screwed up. Okay, so once again, let's see. Can I match the bases? That's always going to be our first question whenever we see an exponential equation. And once again, how do I know this is exponential? Because we have a variable in our exponent. Well, can I match the bases? Let's say we have a 25 and a 1 over 5. Hey, those both can be written as 5 to some power. 25 can be written as 5 squared. And that's to the 4 minus t power. And then 1 over 5 can be written as 5 to the negative 1 power. And we raise that to 3t plus 1. Let's go ahead and use the power to power rule for these. So that would be 5 times 2 to the 4 minus t equals 5 negative 1 times 3t plus 1. We'll go ahead and distribute for those powers. And we'll get 5, 8 minus 2t equals 5 minus 3t minus 1. Now notice the bases are the same, which means we can use the equating rule and just equate the exponents. So 8 minus 2t equals negative 3t minus 1. Let's go ahead and keep solving. 8 minus 2t equals negative 3t minus 1. I'm going to go ahead and I'll move the t's to the left. So we'll add 3t to both sides. And I'll subtract the 8 from both sides. then I have t equals -9. Alrighty, that's our answer. T equals -9. Now for exponential equations, we do not need to check our answers. Let's take a look at exponential equations type 2. So for type 1, remember we could match the bases. Like we did with this problem here, we made them both into 5s. Right there and right there. For exponential equations type 2, the problem is we cannot match the bases. Well, then what's our plan going to be? The plan is going to be you're going to log both sides. Then we're going to use the power rule. Remember, it's this one right here. Log base b of x to the p power equals p times log base b of x. We're going to use that to bring the exponents down to the front and solve. Because remember, our variable is in the exponent. So we're going to want to bring that exponent down so we can solve for a variable. And remember, we're only going to do this if we cannot match the bases. Don't make life harder for yourself than it needs to be. So note, for this class, for Math 103, you're only allowed to solve with the natural or the common logarithms. Once again, the natural would be base e, common log would be base 10. You can't use any other base. Let's take a look at example 3. Solve the following exponential equations. How do I know they're exponential, first off? Well, I have a variable in the exponent. Now the question is, can we match the bases? Because if we can, our life is going to be pretty easy. But notice we have a 2 and a 5. Darn, we can't match those up. So because we can't match them, what's our plan of attack? We're going to log both sides, and we can choose either a common log or a natural log. Now, for this problem, there's no real advantage to either one. If I had a 10 in the problem, I would use a common log. If I had an e in the problem, I would use the natural log. But since I don't have either one, I'm going to go ahead and use the natural log. Why? Because it's shorter to write. Okay, so let's go ahead and copy this down and set it up for logging both sides. Alright, so I'm going to take the log of both sides. I'm going to go ahead and write it in red so you can kind of see what's happening. I'll take the log of both sides. Now you might be saying, gosh, you just made the problem look so much harder. Why'd you do that? Well, remember, why are we doing this? We're doing this so then we can use the power rule, because when we use the power rule, what happens? Our variable comes down to the normal solving line. So then we have 3 ln 2 equals x plus 1 times the natural log of 5. Now once we've done that, we can go ahead and distribute the ln into this binomial. Notice that binomial is not in the argument. Some students get that confused. You can never distribute into the argument, but you can distribute into another binomial. So we'll do that. 3 ln 2 equals x ln 5 plus ln 5. Okay, continuing solving. I'm kind of running out of room. I'm going to go ahead and move that ln 5 to the other side, so I'll subtract that. And I will have x ln 5 equals, definitely running out of room, 3 ln 2 minus ln 5. Then to get x by itself, we'll divide both sides by ln 5. And I have x equals 3 ln 2 minus ln 5 divided by ln 5. And there we go. We've solved that exponential equation. And it definitely got a lot harder when we couldn't match the bases. So if you can match the bases, try it. Because if not, the logarithmic way just tends to take a little longer. Now let's take a look at the next problem. What kind of an equation is this? Well, it's exponential. How do I know that? Variable in the exponent. Okay, plan. I'm going to equate them and then see if we can make the denominators the same. Not the denominators, sorry, the bases the same. So to do that, I'm going to move that 820 to the other side and then see what I can get. So I have 10 to the 5 plus 2x equals, and then so subtracting that out, I'm going to get 48,780. So can I make those bases the same? It doesn't look like that. 48,000 is not 10 to some powder. Not 10 to some power. So because I can't match the bases, I'm going to go ahead and do what? I'm going to log both sides. So the natural log, 10 to 5 plus 2x. And one thing to note, showing me that you're logging both sides is a very important step. That is definitely something I'll be looking for in a problem on the exam. If you do skip this step, that is normally where a lot of the points might be docked. So do bear that in mind when showing your work. Once again, why do we log? We log to bring down the exponent. Because the exponent is what has my variable, and that's what we're solving for. You know what I just realized? It would have been better to use the common log, base 10. Why do I say that? Because if I had used base 10, I could have canceled with that natural log of 10 there. But I didn't, and that's okay. Once again, we're not looking for exact answers in Math 103. For Math 135, you'll start getting into a little more of those specific calculations. Right now, we're just sort of learning how to play with them. Okay, we're trying to solve for x. Let's go ahead and distribute that ln 10 into that binomial. And we get 5 ln 10 plus 2x ln 10 equals ln 4h780. I'm going to go ahead and subtract that 5 ln 10 from both sides. Once again, running out of room, I did not space this one out quite as well as I should have. And we get 2x ln 10 equals ln 48,780 minus 5 ln 10. Okay, once again, we're solving for x. X is right here in between the 2 and the ln 10. We'll go ahead and divide both sides by the 2 ln 10. Let me change my color real quick. And my answer is x equals ln 48780 minus 5 ln 10 divided by 2 ln 10. And there we go. We have our answer. Now, so we've been just working with the exponential equations. We did end up bringing logs in a little bit, but mainly we started out with exponential equations. Now we're moving on to logarithmic equations. And once again, we'll have a type 1 and a type 2 for logarithmic, just like we had a type 1 and type 2 for exponential. So here's a quick question. How do we know when an equation is a logarithmic equation versus an exponential or a quadratic? The answer, well, there is a log in the equation. Notice we have the log term. That is a pretty big signal that we're working with a logarithmic equation. All right, so one thing, let's see. So note, because the argument, and remember, what is the argument? The argument is this value right here, instead of what the log is, I guess you could say it's holding. So the argument of a logarithm must always be positive. Just like in life, if you're ever having a disagreement with someone, make sure your disagreement is, positive, make sure it's productive. Arguments should never be negative. Keep them positive. Okay, so because the argument of a logarithm must be always positive, you will need to check your solutions. Okay, so you do need to check for logarithmic. Alright, so equivalence property of exponential equations. So if b, x, and y are real numbers with b not equal to 1, then log base b of x log base b of x equals log base b of y. So notice the bases are the same, just the arguments are different. This implies that x equals y. So it's a very similar concept to what we had for exponential equations. The bases were the same, set equal to each other, and we just sort of equated them. So for logarithmic equations type 1, there are only logs in the problem. Plan, what are we going to do? Equate the arguments and solve. So what do I mean by only logs in the problem? That means there are no just random numbers hanging out by themselves that aren't logarithmic. So let's take a look at example 4. Notice both of the problems. Those are both logs, and the other one we have log, log, and log. So these are all just log-based problems. So we're good. These are going to be the log type 1, which means they're simpler. We're just going to equate the arguments. So for the first one, these are the two arguments. Oh, first off, back off. You got to check that the bases are the same. That's a log base 2 and a log base 2. Okay, we're good. Now we can equate the arguments. 3x minus 4 equals x plus 2. Solving for x. And we get 2x equals 6, then dividing both sides by 2, we get x equals 3. Now we need to check to make sure that our argument's not negative. So I'll just go ahead and do a quick check up top in red, or you could go ahead and do it. I'll do it on the side actually. So here we go, right out that we're checking our work. So for the first argument, we have 3x minus 4. So that'll be 3 times 3 minus 4, which will end up being 9 minus 4, which is 5. That's positive. We're good. The next one, we have log of x plus 2 from right there. Plugging in 3, we get 3 plus 2, which will be 5. And that is also positive. So we're good. Our answer checks out. It doesn't make any of our arguments negative. Now the next problem, B. Well, there's a slight problem. We don't have just one log equal to another log. We have two logs on one side. So how do we fix that? Well, we can use the quotient rule. Remember, if you see an addition, you can turn it into multiplication. So let's go ahead and do that. All the bases in the problem are the same, so we're good. We'll go ahead and do this. X times x minus 8 equals ln x minus 20. And now we have a log equal to a log. So what can we do? We can equate the arguments. We have x times x minus 8 equals x minus 20. Now let's go ahead, multiply this out. We'll get x squared minus 8x equals x minus 20. Solving for x, minus x from both sides. Ooh, and notice this is a quadratic. So we'll set it equal to 0 and see what we get. So 9x and 20. That looks like x minus 5, x minus 4. So we have two answers. X minus 5 equal to 0. X plus 4 equal to 0. We have x equals negative 4 and x equals 5. Do they both check out? Well, I don't know. I'll go ahead and check. So, for the first one, we just have x. Oh, notice, if we have x and we plug in that negative 4, we'll get a negative argument. So, it doesn't work. Darn. Okay? Extraneous. Makes argument negative. So even if it doesn't work for one of the arguments, you can't use it for the problem. Now let's check 5. Well, if I plug 5 into the first one, ln x, it checks out. But if I plug 5 into the next one, ln x minus 8, that'll be x minus 8. And when I plug in 5, that'll give me a negative 3. So darn, the 5 also doesn't check out. So I'm going to go ahead and just copy my solutions down there. So what will my answer be? Both of my solutions didn't work. Well, the answer is no solution. And my reason is that. Once again, this is my reason, and that was my answer. Okay, so that was logarithmic type 1. Now let's take a look at logarithmic type 2. So in the type 2, how do we identify them? Well, there are regular numbers in the problem, not just logarithms. So what's the plan? Well, the plan is to get the regular numbers on one side of the equal sign and the logarithms on the other. Then, turn the equation into exponential form and solve. Alright, so let's take a look at A. Is this a type 1 or a type 2 logarithm? Well, notice we've got that 8 hanging out by itself, which is just a number. So this is going to be a type 2. How do we solve? Well, we're going to want to turn it into exponential form. But first off, let's go ahead and simplify this. We have that 4 hanging out by the log. So go ahead and divide both sides by that 4. And we'll get log base 3 of 2t minus 7 equals 2. And now let's go ahead and turn this into exponential form. So 3 to the second power gives me that. 3 squared equals 2t minus 7. Now why did we turn it into exponential form? Well, notice our variable is now on the regular solving line. We got it out of the argument. We're good. That's a great way. So that's why we do it. We do it to get the argument, we do it to get the variable out of the argument. Okay, so let's solve. Add 7 to both sides. 3 squared is 9. 9 plus 7 is going to be 16. Dividing both sides by 2, we get 8 equals t. We're not done yet. We need to check. Okay, let's check our answer. So checking. Does it make our argument negative? Nope. We're good. It works out. Now let's go ahead and solve the other problem. So first off, is it a type 1 or type 2 logarithm? And let's back up even more. How do I know it's a logarithmic equation? Well, it has logs in it. Okay, so I know it's logarithmic. Then we need to determine, is it type 1 or type 2? Well, it has that regular number hanging out, so that means it's a type 2. Our plan is to turn it into logarithmic form, which means we need to get the logs to one side. So to do that, I'll add the log base 7 of m to both sides. And we get 2 equals log base 7 of m minus 48 plus log base 7 of m. But we need just one logarithm on this side. So how can I make that addition of logs look like one regular log? Well, we'll use the product rule. So we're going to end up with log base 7 of m times m minus 48. I'll go ahead and simplify that a little further. Log base 7 of m squared minus 40 m. Okay, so now we can turn this into exponential form. So 7 to the second power gives me that. And then we have m squared minus 48m equals 7 squared, which means m squared minus 48m is going to equal 49. Okay, let's go ahead and keep solving. This is quadratic, so we'll go ahead, set it equal to 0, and factor. That looks like m minus 49 and m plus 1 equals 0. Set both equal to 0 to solve. We have two possible answers. M equal to negative 1 and m equal to 49. So once again, this is logarithmic, so we need to check our answers. And for the first logarithm, log base 7 of m. If I plug in 49 into that, it checks out. And if I plug m minus 48, so 49 minus 48, that turns into 1, so that also checks out. Okay, so 49 works. Now let's plug m into the first one. So if m equals negative 1, ooh, that doesn't work. We can't have a negative. We'll go ahead and cross that out. Say extraneous makes argument. You can go ahead and abbreviate argument, argument, negative. Alrighty, so there we go. And we do not solve exponential equations in quadratic form in Math 103. And we also don't cover Objective 3. So that is it for 4.5. So we have the exponential equations, the two different types, the bases are the same, or they're not. And then we have the logarithmic equations, logarithmic equations where we have only logs in the problem, or we have a number as well. Or a regular number, you could say. Alright, that is it for 4.5. Please email me if you have any questions.